Good morning, everyone. Hello and welcome to the Presto conference. First of all, let me thank the Presto conference team for allowing us to present our session on Presto on AWS journey at Twilio. A little bit of introduction about ourselves. My name is Badri Tripathy. I am the senior engineering manager in the data platform team at Twilio. I basically lead the projects around Presto data lake infrastructure and the data processing ingestion framework into the Presto data lake. I have with me my colleague Aakash.
Hey everyone.
He is the principal engineer in the team, and he has years of experience on building data lake and data processing frameworks on Hadoop platform. So in the next 20 to 25 minutes, we are going to cover the data lake evolution journey at Twilio, the current data scale, what we are operating at Twilio, and the role of Presto in the data ecosystem at Twilio, the current query challenges, the optimization techniques at Twilio. So before we jump into the Presto and the data lake ecosystem at Twilio, I would like to give you a quick introduction about Twilio. So Twilio is a customer engagement platform which basically enables the business to connect or to engage with the customers through various APIs, through different channels of communication like messaging APIs, voice APIs, contact center APIs. I think most of us in this room might have used Uber cab service. So the text messages or the calls which you receive from the Uber is backed by the Twilio data platform. Similarly, a lot of banking authentication notification things, whatever text messages you guys are receiving, those are all powered by Twilio platform. So as you can see, like all these products like messaging, calls, they generate a lot of large volume of data, and that basically goes to the data platform, data lake, and on which warehouse data marts are built for different analytical use cases like for finance, marketing, sales, etc. So let's understand what has been the data lake journey at Twilio. So our 80% of the data comes from this thing, the product teams which generate the data, pipe their data through Kafka, or put it into MySQL database. There is a bunch of data also coming from third-party data sources like Salesforce, Zendesk, Marketo, the third-party basically API-powered data. And then we have a bunch of data coming from internal CSV, like different accounting or finance team, they generate a lot of CSVs. So all these data sources basically are put into the S3 data lake through config-driven Python and Spark-based loaders. So prior to 2020-21, we used to pump this data at the S3 data lake to Redshift, and Redshift was solely used for our query purpose, for analytical queries or business use cases. And then the Looker or different dashboarding BI layer was on top of Redshift. So things were running fine till 2020-21, but once our data grew beyond 5 petabytes, 7 petabytes, we started facing the issues on like managing Redshift at the scale which the data grew in Twilio. So we had to add more and more nodes in the Redshift thing. And you can see we have to always maintain 2 copies of data. One is that's the S3 data lake, the data at the S3, and then one at the Redshift because Redshift has the coupled storage and compute layer. So it was difficult to manage once the data volume grew at Redshift. So either you cap your cost or you take the hit on the performance side of the thing. So then we had to look for a solution where the storage and compute layer can be disintegrated, can be decoupled. So there comes Presto as a solution for us. So now, over the years, we have added more use cases, more data sources like Snowflake, BigQuery have also been added to other sources which I discussed in the previous slide. And all this goes into our S3 data lake first. And on the top of that, we have Spark, Python, and Presto SQL as our transformation layer, which generates a lot of transform data sets. And those are also getting pushed into our S3 data lake. So now on S3, we have our raw data lake, which is coming from our product sources, product teams, and also the transform data sets. And everything is kind of exposed as Presto external tables on on the Presto layer. And on top of Presto, we have our views, Tableau extracts, and other BI use cases or ML use cases, getting the use of, using the Presto views and Presto extracts or tables. So let's understand the current data scale for Twilio today. So our raw data lake is around 12 petabytes of data, which is having on the based on Hoodie, Parquet, JSON format. Mostly it is on the Hoodie. Then we have our warehouse data lake, data source, data getting generated on S3 itself. Those are all at Parquet format. And everything is kind of backed by 3,000 dataset loaders, 500 dataset ETL jobs. Coming to the Presto cluster thing, we have 5 dedicated different clusters, each dedicated for its own use case. We'll discuss in the next slide. And all the 5 clusters are operating on 600 plus nodes today. And Twilio is heavily on the AWS infrastructure. We have the EC2 instances of R5 instances, and categorically we have chosen them because they are quite efficient for memory intensive operations and which are good for big data analytical use cases. And today we have around 2,700, more than 2,700 Twilions who are actually banking on the Presto infrastructure for their query or BI use cases. And we have found like almost we are running 1 million queries on Presto infrastructure, and which are being used for 5,000 BI reports, dashboards. And over a month, we normally kind of scan around 40 petabytes of data. So it just gives you a glimpse of like how heavily Presto is being used at Twilio. So let's understand the different use cases what Presto is basically supporting in Twilio. So 80% of the use case, as I discussed in the previous slide, is on the reporting and dashboarding use cases. Very complex business calculations, calculating the gross margin revenue or sales pipeline, forecasting, and different other analytical use cases are being served. Almost 5,000 plus reports are running on Presto. Then we have a dedicated cluster, and the reporting and dashboard use cases are being supported by 2 different clusters, almost operating around 350 to 400 nodes. So we have enabled the autoscale feature on that. And basically, we use the ELB feature to route the queries so that things can run in parallel. And we'll discuss more detail into the technical details of that in the next slides. We have one dedicated cluster for highly mission critical E-level reporting purpose. That particular cluster is also supporting a lot of web-based API queries where it is a dire need of having a low latency response query time, query response time. And we have achieved till around 7 to 8 seconds of response time in that for that particular use case. And then we have one particular cluster for our ad hoc and exploratory query purpose. And of course, the last one is that the custom ETLs, which basically Presto SQL is used to transform our data sets in a batch mode and generate the transformed data sets. So to support all these cases, we have our own set of query challenges today. So the most common query challenge we face is that the noisy neighbor problem. Since Presto is a shared cluster and every team is using it, it might happen, and it is being used by a lot of non-technical teams like finance, marketing, and their analysts or their support engineers. They simply fire any query at any point of time. So it is very difficult to control that thing. So it might happen in a use case like one inefficient query can hamper the performance of the other queries parallelly running at the same point of time. Similarly, since we are almost operating on the AWS infrastructure and needing almost 600 nodes, there is always a challenge to maintain your query. The query infrastructure operating in the optimum level. The cost should be in a controlled manner. So that is the biggest challenge. And we have seen the third use case is an interesting use case. Like we have some critical reports running at the month-end time, and during that time, sporadically, one team might fire around 500, 600 queries at, in a very random time. So that can affect very critical, hamper many critical queries being run at that point. So it's basically the unequal cluster resource consumption, or you have a skewed cluster consumption at one point of time. Then Presto, as I told, like many teams write very, very complex, big views, complex queries, joins, though that they take a lot of time to process in Presto. So we face that issue also. And then of course we have the other challenges of maintaining the cluster up and running for and health monitoring the things. So let's understand what are the optimizations what we are doing today. So broadly we have classified our optimizations into 3 techniques, like one is based on the query log analysis. We generate a lot of log on our queries, and we use that log for our performance optimization. And this is basically based on the premise like you guardrail your system so that it cannot be abused, or you make the system so efficient that anything that runs to the system can be run at its most optimum level. Then we have our cost optimizations. So basically we have focused on the data transfer rate and the data compression thing so that your AWS EC2 data transfer rate can be lowered. And of course the third one is the reliability optimizations. You make sure that your cluster is up and running 24/7. So let's double click on this performance optimization thing. So we have, we basically take 3 parameters. This query frequency, like at single point of time, a similar query is running for similar instance of the query is running for a larger number of times. Or the query high runtime, we analyze like which query is taking a lot of time to complete. And then any query which is basically scanning a lot of data. So these 3 parameters basically guides us the optimization technique, as I discussed earlier. Either we kind of help to kind of prevent it to abuse the query system, that is on the guardrailing thing, or else you limit the number of resources for that particular team so that they can access the system in a controlled manner. And of course, time to time again, we keep on analyzing the log and identify the opportunities for how to cube the data. So rest of the performance techniques, I'll hand over to Aakash to take it forward from here. Thank you.
Thanks, Badri. So let's deep dive more into the performance optimization. So the way you operate Presto in a very multi-tenant environment in Twilio, so to make sure that one user and group doesn't like hog entire cluster, we heavily use the hierarchical resource management in Presto. We define different groups and subgroups. We try to limit how much max memory they can use, how much max concurrency they can have, like how many queries they can run in parallel. At the same time, how much is the number of queries they can queue. On top of that, as Badri told, we have multiple clusters running, like 4 or 5 clusters, each with the different use cases. That gives us the ability to tune each one separately, like either use separate EC2 instance or the resource grouping and all can go differently, and use different Presto parameters also to tune them. Despite having this all resource management to make it multi-tenant, sometimes we see that a particular group or user can run a very inefficient query, and that can consume the entire resource for that particular group. In order to avoid that, we have added some guardrails, and these guardrails either will avoid any duplicate queries, any missing partitions, the query which is running with missing partitions and all that. And we generally tag, and based on the configuration, we kill those kind of queries also based on the use cases. And those tagging and all that, we store those all metadata information in a Presto table again. I'm going to talk later on how we do that. But like what we do is with that table, we time to time we go through that and communicate to user also that these kind of query you run, which is inefficient, so that they can improve their Presto SQL queries. So now to getting onto the how do we implement these guardrails, let's go into the diagram in the right side first. So we leverage for all the guardrailings and all, we leverage event listener extensively, and we have customized our code over there. So event listener does 3 things for us. Whenever the query created event comes, it goes through in the real time, it goes through all the filtering and see the guardrails and all that, whether that filter out or not the query. When the query completed events happen, we collect all the stats, we dump into the Kafka, which eventually get into the S3 with our data pipeline and data stored in the Hoodie, and that table we expose again with the Presto to analyze it further. The third application over there is that we calculate a lot of metrics over there, like how many queries are failing with internal errors, insufficient errors, or the external errors. On those kind of metrics also we trigger from there. Just to look into one example, how do we catch the duplicate queries? So in event listener, we have in-memory cache, which has the current state of the query which is running. So whenever the new query comes, we look into the particular user ID context and see whether that query is already running. If it's parallelly already executing, then we tag them that this is a duplicate query. And if based on the configurations, if you're allowed to kill that query also. And that tagging again goes through the whole query stats into the Kafka. Similar framework we extended also to identify whether the query has the missing partitions. And for that, we use the Presto SQL parser to parse the query and see that if against a given table, we have the partition column used or not. And for some of the large tables, that's really impact ours. So just if you look at the duplicate query impact in our cluster, we save 5 to 10% of the resource overall. Now with the query stats which we collected in the whole event listener, we also do the post-processing for that and see what kind of common queries they are running which taking a lot of time or going through the insufficient resource problem and all that. And based on that, we try to see if the cubing can help us to solve that problem. And in our experience, sometimes we reduce the whole execution time from hours to few minutes of the cubing. On top of that, we regularly run the analyze tables to get all the stats, which helps a lot in the joining and other Presto optimization. And I will highly suggest that using that regularly. Since we have a lot of information with the Presto query stats, that each query, how much I/O time it took, how much CPU time it took, we are building a whole chargeback model for doing that. Apart from that also, when we analyze our query a lot, we saw that a lot of queries are running for 1 or 2 hours and then getting killed because most of the time, the Presto is MPP system, some of the fault tolerance are missing there. So for those cases, we are using extensively now looking into the Presto and Spark. Right now, that's in work in progress. And all the cubing I talked about also in the last slide, those also we are planning to go everything through Presto and Spark on doing that. Apart from that, some of the optimization we have done with Hoodie is that our 30 to 40% data set as of now in Hoodie, and we are growing that data set. We were using Presto 247, and we found that S3 listing itself was taking for some of the tables like 20 minutes and plus. So we try to use the Hoodie 11, which is 11 in Presto 275. We did all the benchmarking for that, and right now it's almost like 5x faster for us. In that process, we have some caveat also, which I'm going to talk through. So one is, if you have a Hoodie table with empty partitions, your query may fail. And for that, you can use this session flag. In our fork, we basically have this enabled by default, and that's working for us. The second caveat we have is that some of the data set we have, it has a Parquet file which has a corrupted statistics. And by corrupted statistics, I mean the generally Parquet file store the mean and max. And for some of the binary column, it may possible that mean is greater than the max. In that case, your query will fail, saying that is a corrupted statistics there. To avoid that, you can use this flag. But we found this issue with 275. We reported it. It's got fixed in 278. Because of some Hoodie problem, we cannot consume the 278. So we have cherry-picked that PR, and it's working for us. On coming to the cost optimization, some of the we have done. So generally, with Presto, we operate again in the good practices in AWS that you deploy your Presto in equally distributed among AZs. So in our case, if you give the 90-node cluster, Presto cluster, we will have 3 AZs, each one with 30 nodes. This was working good for us, but as the user base grown and the data size grown, at one point of time, the cost surges so much that we were estimating almost 2 million plus for overall cost. And then when we investigated, we found out that during the shuffle phase and the other joining and all that, there's a lot of data transfer happening between the nodes. And if it happens, the nodes are sitting in different AZs, then AWS will charge you for the data transfer. And we identified that that was almost like 2 million plus for that was exactly the reason for that. So you see all the red arrows, they're like different nodes sitting in the different AZs, that's what is the problem. So we took to a step to fix this. One thing we started to use is we enabled the compression flag. Somehow it's not that open in the document, but if you look in the code, this flag is there. Once we enable that, our cost itself goes down almost 30%. When we did some of the benchmarking, because we are enabling compressing, it will have a hit on the CPU. We saw that the CPU for overall use is 20 to 30% higher now. Interestingly more, some of the join queries are running 20% faster now. And it may be because of the data transfer happening less now because it's compressed and less I/O weight. Similarly, some of the count queries, which is CPU heavy, they are 10% slower now. This whole sampling has been done on the Twilio dataset. It's not a TPC benchmarking. So whatever the sample we had, the heavy query, which you even use in Twilio environment. So I wanted to share with you guys. The second step we did is we looked into whole that AWS transfer, like whole this deployment set, and we were looking into really evaluation, like whether the Presto or a multi-AG works or not. And if this case, if you look at, if your query tasks are distributed across these all AGs, and if one AG goes down, your query task will fail. So basically, the query will also fail. So like we were like even we're trying to be AG agnostic, but that's not working for us. So we changed the whole deployment model now, and we like, okay, just deploy one Presto cluster in one AG itself. And we use the Terraform and AWS auto-scaling group to provision that. They are really stable, and we are kind of loving so far for it. It's a really impressive one. So now our entire Presto cluster moved to a single AG. And for some of the critical resources which require critical business use cases, we put a load balancer, and behind that load balancer, we have multiple clusters now, and each one in separate AZs, so that even if one AZ goes down, our business keeps running. Maybe some percentage of query will impact it, but rest of them should be fine. And that's actually saving us so much money that from instead of being like 2 million plus, we're now estimating it's 70,000. Some of the other optimization we also have done is that on evaluating the query, analyzing the queries, we found out that most of the queries coming for the last query itself. So we glycerize all the older data. We build a whole lifecycle policy for that. And since the query is running and some of the file are getting to glycerize because of the lifecycle policy, so we enable this flag, which helps us to avoid any exception because of that. Coming back to the reliability optimization, we are heavily backing on the AWS ASG to give all the metrics, cluster-wide metrics, like how much CPU utilization it has, and all the other kind of information we have. We also enable the Presto JMX metrics to get insight into how the queries are running, how much CPU taking, and all those information. And as I talked earlier in slides with the event listener, we have some custom metrics also. So we have a ton of alerting, but these are some of the important which I want to share with you. One is that to make sure that whether the cluster in a particular AZ is working or not, we are banking on this one, that AWS ASG expose how many nodes are in service versus how much is the desired capacity is. And we find that it's less than 80%, means something going wrong. And in our experience, we found out either that AG doesn't have the instance type you are looking for, or that AG has some network issue or something that is recognizing nodes are unhealthy. So then we require some manual intervention. Either you deploy the cluster somewhere else or do some action over there. The second one is that we also look into how many internal error happening and insufficient resource error happening. And that means that if more than 30% of error happening over there, internal error plus insufficient error, means something is wrong with your whole cluster setup. And then again, that requires some manual intervention to look into. We have a continuous process to make sure that Presto is available for the customers who are doing the JDBC connection with Looker and Tableau and all that. And for that, we keep constantly check whether the Presto coordinator is available, as well as the connection is working with all the sorts and everything. So that's another monitoring process we have. Coming to auto scaling, most all the clusters in our environment are auto scaled. They're using the AWS ASG feature for that. Right now, we are auto scaling on the CPU. If the CPU uses more than 75%, we aggressively auto scale the cluster by either 20% or more. Since we have every cluster separate, we can configure that. But we also make sure that when you scale down, you are pretty slow over that. Like instead of going 20% aggressive, you go down in small batches. So to make sure that queries are running, they're not getting impacted because nodes is terminated and all that. Since we have a lot of query stats and all, which I talked earlier, time to time on a schedule basis, we also look into the failed queries. We see that what kind of the feedback we can get, whether they are failing because of the cluster size, they are not getting enough resources, or they are failing because of the resource grouping constraint we put on there. So we take those feedbacks and see how to improve those groupings and all that. Besides that, Twilio is an enterprise company, so access and governance is very high priority here. As of now, we built an in-house project to manage that, to manage all the access. They are the table level access as of now. We heavily backed on the LDAP for all the authorization and authentication. So that I will talk the two most important key takeaway I want to take with you. One is that always work on the guardrail to avoid TrustGF commons, either using the event listener framework or something, because you are running Presto in a multi-tenant environment, guardrails play a very important role. Second one is look into the cost optimization in your design itself. Presto tend to get very costly very soon. So apart from investing a lot on the performance improvement, also look into the cost optimization technique. The one we kind of use, probably that may help you. With that, I will open for the questions. Do you have any questions? Sorry? So with auto scaling, we are using the AWS ASG provided feature over there. They have a bunch of different kind of auto scaling you can have. They have predictive auto scaling also, which you haven't using that. But as of now, we are auto scaling based on the CPU utilization. So for each cluster, we kind of set individually that if it is more than 75% or something, then the auto scale get triggered. And then auto scale we trigger little aggressively, like more than add 20% capacity or something more over there. And we have another setting also over there in ASG, which says that, okay, if the CPU utilization is less than 20%, means the cluster is ready to scale down, and then you, in batches of 10%, you scale down. We are looking into more advancement over there. Right now, we are only based on CPU utilization, but we are trying to build a different process which can take the number of queries in the queue, memory utilization, and CPU utilization combined, and then emit that matrix which we can act upon. So, yeah, that's a very interesting question. So as of now, we are using the load balancer to balance the load across the queries. And there is a different technologies and there is a different conflict with that. As of now, the Tableau doesn't support multiple cluster. So you have to tie it up with one cluster. Similarly, Looker can support multiple clusters, so that's okay. DataGrip can support multiple users. So in some of the cases, like in the Tableau, we have connected it to cluster one. And in that way, we provision the cluster one a little bigger, like maybe 300 nodes or 400 nodes. Where since the Looker and all the DataGrip loads supposed to be balanced equally, the cluster two is smaller and that can take up a load. We are using the load balancer, the AWS load balancer with a stickiness feature so that the queries can run longer and they get result. We are reaching a point that we are seeing the distribution is not happening equally. So we are looking into something like Presto Gateway also. Yes, sir.
How do you sync up the data between those two clusters? Is there some mission critical queries that you want to run right?
Sure. So generally, because Presto is only compute layer, the data is sitting in S3. So nothing to be shared from that background, but if we define a stickiness, so if one particular user went to one cluster, we define the stickiness, so next 6 hours something, it will be associated with that cluster itself. So all the result and all they can paginate through that itself.
So to add to that, this is just a compute layer. Compute only is getting distributed across the thing, but ultimately they write the data to S3. So the syncing part, I think you were asking about the S3 thing. So no, we have the common data layer where all these two compute nodes, they can parallelly process the queries, but write it to the same S3 thing. It's just load balancing the number of queries running parallel across the cluster.
Thanks, Badri. Yes, something.
How do you keep the cubes updated?
Sorry?
Yeah, that's an important question. And so in our case, we are right now, the cube, we are running on Presto and Spark, and that's, we are trying to write everything in Hoodie again. So incrementally, it keeps updating that. And we are kind of running that on a schedule basis, whatever, and we're trying to build that as a self-service environment where customer can come and define that. Either it can be event-based. So if the base table get updated, then you trigger this, like the whole cubing process to add that. Or you can have a schedule basis based on the use case what you define on.
It's a scheduled ETL job basically. You identified, okay, these things can be run as a batch ETL. You schedule that, or as Aakash mentioned, like you can make it also event based by attaching it to the Airflow DAG. So taking help of is good. Yep, please.
Yeah. Yeah, so the question is around reliability. You guys mentioned about there are some reliability issue with coordinators that you face. Have you guys considered using multi-coordinator support that's been there for some time?
We haven't as of now, and probably we are looking for something. I guess some new project came in Presto, I'm forgetting the name, that we we didn't get time to explore that, but
So
that's a good thing. We're supposed to be doing that.
Yeah,
So-
and a follow-up question around reliability. You guys mentioned based on events, you are killing queries. I think there are some inbuilt support also for killing queries. Have you guys considered adding some of your supports into the system so that other people can leverage?
So the event listener project, we are right now in work in progress. We are kind of testing a lot. Once it's in good stage, we are thinking of open sourcing that also. So some of the common codes can be leveraged across.
So we have invested a lot there, like in that particular piece of thing.
Quick question. So I was looking at your infrastructures. Do you use different infrastructures for your more interactive dashboard queries so that you can cache that data? Because I saw a lot of them. I don't know if you use a lot of that. And what do you do with them? Do you typically keep them up for a while, or do you actually destroy them once you're done?
But do you want to take that?
Sorry, can you please repeat that?
Yeah. So do you use a lot of fast storage attached to your infrastructures for caching purposes with use cases related to like dashboarding and more interactive?
Yeah. So the caching thing, we are heavily banking on the Tableau extracts or the Looker cache. We tried to use the Alexio open sourcing on Presto, but we had some issues regarding the data consistency thing. So for this 2022 year, we are not using that in production yet. We are spiking on that thing. But regarding your caching thing, we are heavily depending on the BI side of the world. At Presto side, we are not caching anything as of now.
On top of that, we are debating also whether the Presto should be fast enough that a query response is second. So whether you need to cache or do the,
Yeah.
and since we are doing the cubing also, we are right now in that conflict with which way we should go.
So we are taking a balanced approach. If anything is very mission critical, we have a dedicated cluster for that. I think I covered that, like we are hitting around 7 to 8 seconds of low latency response time there.
So related to the auto scaling question, just now, how do you guys auto scale without restarting the cluster? Because we're trying to kind of do the same thing, but we can only scale down, but not scaling up because of the hard-coded addresses in coordinator.
So for us, like a hardcore, this one, like the coordinator, we provided an elastic IP for that, as well as we built that whole HA proxy envoy layer that it can be self-service discovered over there. So like for us, the scaling up is like spawning more new node with the Terraform and then just running the whole configuration management through Safe. So the Presto worker and all this comes in action. And then it look for the discovery service that, okay, whether this EIP is in existence, whichever the latest one, and takes that and has started to communicate as a coordinator.
And how do you deal with the cache then?
Like cache, like, sorry, can you?
Cache.
Like in which sense? Can you come again?
No, as I told, like cache is not on the Presto layer as of now. So we are heavily banking on the BI side of the thing. Alexio we tried last year, but there was some data consistency issues. So we have not made that thing into production yet. So Presto layer, there is no caching yet in our infrastructure.
I see. Thank you.
Sure.
So was there any analysis between the partitions and also the number of files for the HUD table and also the worker nodes, number of worker nodes?
That's a very interesting question. Since we are using Hoodie has the inbuilt feature how much file and it can be this one. So that's helping us a lot over there, like how much file can present or not. But at the same time, we are also trying to leverage the Hoodie clustering technology to cluster more. That's one aspect of that. But some of the Parquet file that has a small file problem as of now. And we are trying to change that with adding the more. So we found that if the file size is generally 500 MB to 1 GB, they're performing much heavier, much better than the file which is like 100 MB or less than that. So that's there. We are like, so all the new data set, we're trying to be open with the Hoodie itself, and Hoodie is providing that feature for us. Does that answer your question? Yes.
You mentioned you have like multiple clusters and stuff. So do you use any proxy to kind of manage your workload between different clusters, or any rules in between to kind of make decisions?
No, as of now, since we have only a handful of the clusters, and we define the use cases they're gonna serve. So most of the customer, they know what cluster they have to go for. And since it's we added the ALB and all for that, so it's pretty easy name for them that they're gonna be using that. But as we are growing, we are adding more clusters, and probably in future with the Terraform and all, we can add more clusters. So we are looking into Presto Gateway and Presto Router to have that kind of feature where you can do a lot of intelligence that, okay, look into the plan, see whether it's a memory intensive or CPU intensive, and route them on the different clusters.
Okay, so like you mentioned, like you have different clusters for like different set of users. So
Yes.
As of now, no proxy in between.
No.
Okay, thank you.
Sure. Yes. Iceberg table, as of now, no. We are mostly using the hoodie. Most of the use cases in Twilio is very much upserts, like Uber. We have keep updates 30 days back of data and all that. So we intensely went for the hoodie. When we were looking into that like 2 years back, the Iceberg was still in the process. We liked Iceberg a lot with the specification and everything, but that time the update was not implemented, so we went with the hoodie route. Now we build all the ecosystem, so we are continuing with that, but that may change in the future.
Can you talk a little bit on the ingestion, data ingestion?
Sure. So as Badri talked about in the very beginning slides, let me go through that. So we have, go ahead, Badri.
Yeah, so we have any specific question regarding, these are all like config-driven Python-based and Spark-based Scala code. So basically you configure your data source and then it pulls the data from Kafka or S3 files and load it to the Presto data lake.
So if you look at the left column, just to add on that, if you look at the leftmost column, those are the different data sets we have. As Badri told initially, the most of the data is coming from Kafka pipeline. Then we have a bunch of the admin job. We have internal names for that. So these are the Spark jobs, which does a lot of deduplication and all those kind of processing, and then put that in S3 bucket, which we call it data lake for our Twilio. Similarly, we have like a Snowflake and BigQuery, which for them, we generally does a custom job, which dump the S3, files on S3. The third-party data source, which coming from Salesforce and all Gendex and all those kind of customer platforms, we use, as of now, we use the Meltano and Singer as a separate pipeline service to read those data and dump again on that data lake. Some of the salesperson and all, they have their own Excel sheet. They don't like to get in the other platforms, so we have to support those CSVs also. We built an internal UI for them to upload their files, which get written to S3. Now, based on the S3, this is exposed directly to S3, directly with Presto. But in the meantime, we have some other transformation also, like creating the join tables, cubing, and all those, and use Presto itself to like combine a couple of tables and get the data finally. So those are living in the data warehouse bucket, and Presto is access to both these buckets and exposed as a table. Sure.
I wanted to know what's the biggest join query you've seen, like how many tables?
We have like a lot of users are analysts. Sometimes they write the SQL, which is 1800 line plus, and that's almost like 7 to 8 tables joins they do, and that join goes around like year worth of data. That may be a couple of petabyte of data they join that. So in general case, look in the one simple example is that Twilio is a communication platform, so you want to know in which country how many messages have been sent. So they need to join message data, which is huge, considering the scale, then with country, then with account, then with pricing. So at least like 6, 7 tables they do that, and a couple of petabytes they join.
So I think we're at time, maybe one more question, and then we'll move it out for more Q&A.
Sure.
Yeah.
Have you done any comparative analysis with Athena?
Yes, we are in the process of doing that. We are, in fact, we have in Presto on us, like in-house. We are comparing with the Galaxy also and Athena also. Athena performance come out good because and the costing is the biggest advantage over there because the cost on the data scanned. And some of the query we ran over there, it's kind of like performance-wise is okay. It's still a Trino engine, so it works good. But Athena, in my sense, doesn't provide that many knobs to you. So we found some of the query which is very high on CPU. They keep failing. Even if you increase the timeout, it doesn't work that much. And since the black box, you cannot do much over there. Okay, but in general, for the like other queries, it works well for us. Like whatever we experimented, it seems like a good potential for us also. Cool. So is that okay? Thank you guys.
Thank you all.